Lesson 24 is Maxwell's theory of electromagnetism. And the first thing you should do is go to YouTube and Google the electromagnetic radiation song. Here's what it looks like. It's by Emerson, Fu, and Wang Yang, and it is probably my favorite song of all time. It's absolute gold. It's a classic. You have to watch this video. And then you'll have a whole new appreciation for the electromagnetic spectrum. So go ahead and do that. I'd show it on this recording here, except for you can't hear the sound, so that's kind of useless. So watch that video and then come back to your lesson. And here's poor old James Clerk Maxwell, who was a brilliant physicist and unfortunately died at age 48. Before a lot of his work was, the magnitude of his work was even appreciated. His greatest accomplishment, it says here, was the theory of electromagnetism. We've discussed Oersted and Ampere's law. We've discussed Faraday's law of induction. Maxwell came up with a theory that unites everything, and he came up with these rules about electromagnetic radiation, that electromagnetic radiation is produced whenever a charge accelerates. So it has to be accelerating, not moving at constant velocity. It must be accelerating, because that accelerating charge will create a changing magnetic field, and that changing magnetic field creates a changing magnetic field, which will in turn create its own changing magnetic field, and so on and so on, and you get electromagnetic radiation, which is a form of energy. He also said that the frequency that a charge jiggles back and forth with will exactly match the frequency of the EMR produced. So, for example, if you have a radio antenna, which is obviously going to produce radio waves, and you have an electron in that antenna and it's going back and forth up, and if an electron is doing this, then by definition it must be accelerating, because it has to be having a velocity of 0 here and a 0 here, so it's accelerating all the time. So the electron goes back and forth, and let's say it's going 1, 2, 3, 4, 5, 6. I'm trying to do it once per second. So if that's how the electron is moving, it's going to have a frequency of 1 hertz, 1 cycle per second. Okay, which is not the frequency of most radio waves, but that's an example of the frequency. And when we're getting onto electromagnetic radiation with higher frequencies, you're talking about values like 1 times 10 to the 14 hertz. So these things are going back and forth like really, 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 really fast. And those are the high energy forms of electromagnetic radiation. Number 3, all EMR travels at the speed of light, which is our next lesson. A fantastic lesson on how we calculate the speed of light. And there's the value you should know for the speed of light, 3 times 10 to the 8 meters per second. Number 4, the electric and magnetic fields are perpendicular to each other and perpendicular to the direction the wave is traveling. Just refer to the previous lesson where I had that animation of the electromagnetic wave, and it's always, the fields are always perpendicular to one another. And then the electromagnetic radiation will do all things any transverse wave can do, like refraction, interference, polarization, and we'll get onto those things later on in life. And then the next part of this lesson just goes to, talks about Heinrich Hertz, and just gives an example of how they're trying to demonstrate here on a 2-dimensional screen how this works in 3 dimensions. So it's kind of tricky to look at, but basically we have an AC generator. AC means alternating current. It means the current will switch directions every now and not every now, on a regular basis, on a regular repeating period, it will switch directions, and therefore the direction of the current will switch. So here we have the positive here and the negative here, and then down in the second one, the negative's up here and the positive is down there. And it's just trying to depict the electric field and the magnetic field and how they're going back and forth, and they're perpendicular to one another. So you can read over that. It's a difficult thing to visualize because you have to try and visualize this in 3 dimensions. And that pretty much wraps it up for lesson 24. Let's move on to, so just to review, the important things that you want to know from this lesson are right here. Maxwell's predictions on or Maxwell's theory of electromagnetism and the rules that govern EMR. On to lesson 25, the speed of light.